start with the Kioptrix level 1 with the Apache machines. And over here, we can see the interface. And we're going to try the machine called Kioptrix of the Apache blocks, which is vulnerable machines. So the very first important thing, we're going to try our methodology to identify the loopholes and the vulnerabilities. So I use NetDiscover to identify the local network, which is 106. And we can see this is a PCS, systematic machine. So the very first thing which I'm going to do, I'm going to simply make all the things in a folder. I'm going to put I will make a report. So first I'm going to do an Nmap. I'm going to do SV for the serviceless version. Let's see the operating system with capital O and -p icon. So -p icon to scan the entire port numbers on the server side. And if you want to use this one, you can use. Otherwise, SV will use the -p on his own server. So and for saving your output, so I'm going to put on this one on the root desktop, and I'm going to name this one Kiop level 1.txt and the IP address. So through this command, we can see that I'm using SS for the sync scan to identify the open ports, SV for the serviceless version, -O for operating system, -p to scan the entire port number, -on to save the output of my specific folder, which will be a kioptrix.txt on the desktop folder. So if you see over here, the file is already created. So our main objective will be to identify each and every loopholes on the server side one by one. And if you look over here, the scan has been done, and I can see the output from the Kioptrix machine. And if you go over here, you will see an output has been saved in a txt file. And why I'm showing this one, because you can see you can simply make your own PPT files. So all you can put in the name. So I'm going to name this Kioptrix, Kiop, and I'm going to save it over here. And we're going to put this one on a folder. So that's right. Let's do recon. So on the recon, I put the file over here. So in the recon, you can write a folder over here again and put Nmap scan for remember your techniques. So still we are doing a reconstitution, means we are going to gather the information about the target. Or either you can do a screenshot. So if I'm simply doing a screenshot, it will save it over here. You can also put this one on your file for the presentation type. Before attacking phase, let's gather the information that we can see the port number 80 is available. We are not going to, for looking for the further steps, we can see that this is a Unix system with a Red Hat Linux operating system. So if I simply visit that page on the server side, I can see there's a default test page, which is an Apache server page. And so what I'm going to do, I'm going to use a tool called Webalizer. Webalizer extension for firewall for recon information gathering. So over here, I'm going to use the second one because the first one was from for Firefox. For Chrome, I'm going to use it for Mozilla Firefox. So it's down. The main objective of using Webalizer to identify each and every services which is running in the backend of the server. For example, you can see there's a tab over here. So I'm going to use yes, accept. So when I accept the Webalizer's cookies, we can see that what are the technologies they are using on the web server. For example, JavaScript framework, and you can see JS, you can see programming language they are using Node.js, and we can see the payment processor they are using Stripe. For payment processor, you can see they are using Stripe. For example, I'm going to use this Webalizer in this website. So when I simply refresh the website, I can see that through the Webalizer, I can identify which are the servers they are using. For example, they are using Apache, the 1.3.20, The operating system they are using is Unix, and the web server extension they are using OpenSSL and Mode Ssl with their versions. So our main objective will be to identify the directories on the server side. So this is also part of the recon part. So let's use the crawling process to identify the number of directories which is hidden on the server side. For that case, I'm going to use a tool called Buster. So Buster is basically used to crawl the entire network to identify the hidden directories on the server side. So we're going to use one by one all the tools in our entire syllabus. So I'm going to use the IP address, the number of threads according to my server, and the word list. So we're going to use the word list from the root directory, from the user share. We're going to type word list. You can see there's a word list directory, and in the word list I'm going to use the Buster, and we can see there are lots of other dictionaries. So these are basically dictionaries which contain some words related to directory. It will perform some kind of brute force attack. So you can use the large, the TX, the 1.0, the 2.3, the medium, small, the lower cases. So I'm going to use the small one, or you can use the medium one. So, and we're going to remove the recursive, and we're going to look for the brute force for directories, brute force for the files. And if you see over here, remember your opponent, which programming language they are using for running their website. So if you doesn't know, write the default one. If you know, you can change the extension, and you can start. So the main objective of your type 3 Buster to identify each and a directory on the server side. So you can see these are the words which will take to scan the entire network. 4,41,134. So still they are scanning the server, and the times left. So you can see over here they're searching for the directories and with the file extension. So if you see the result, you will see all the files and the directories which is totally messed up over here. But you can see the response code. Through the response code, you can identify that. So the most important part is to recon or simply enumerate the services. These are the files, these are the directories, and if you see the result in the tree view, you will see like this architecture, which contains all the files in a proper manner way. You can see CGI bin, which is a directory on the server side, the icon directory, the doc directory, which contains a file called test.php, and we have a manual. We have some users and MRTH also, and if you find some errors, you will show over here. For example, you can see this is 403, which is forbidden, but we can see there we can access the file which is test.php showing 200. So in the test.php, we can see a single file over there which contains nothing. So before information gathering, the crawl has been done. Let's see what we have in the test.php file. So over here, they have given us message. This is this page is used for test proper operation for the Apache web server. Okay. After it has been installed. Okay. So if you can read this page, it means the web page server installed in the site is working properly. Okay, that's cool. This is a testing website, so it's an Apache website. So you have no add contents on your directory. Please replace the page. Not that you saw people visiting your website to see pages and not your content. Okay. So we have, if you have upgraded from Red Hat Linux, okay, so over here we can see if you have upgraded from Red Hat Linux 6.2 and earlier, then you are seeing this page because of the document.root, which is set on etc http config. Okay, so this file over here, etc http config http.config file is a directory of your Apache server of Red Hat. You can simply check of your Kali Linux. You can go to the other location in the computers. You can see the etc In the etc, you will see Apache 2. This is the directory where all the configuration files of your Apache server with the ports configuration, with the Apache configurations also. So, but this is a Kali Linux, and that's a Red Hat, a SandOS system. Each and every server has their different location of each file. So we can see that any subdirectories which existed under the home HTTP file, the home HTTP which contains the usernames, and HTTP is also a user when you're using an Apache server. So should we move to where www, where the location of our website hosting. So we can see in the var www file, we can access our Apache server's configuration, or you can say hosting applications. So it contains the var www when you move to a home HTTPD, and configuration file can be updated accordingly. So we have a message that it's a Red Hat Linux system, or we can also gather the information from the you can see the Nmap scan, and we can see over here that it showed us that it's a Red Hat Linux system. And we can see the Apache version, which is 1.3.20, and they are simply said if you upgrade it from Linux 6.2, then you are seeing this page. So we have a hint. So in the dir buster has been completed, and I see there is nothing related, anything to the web server, which could be useful for me. But if you didn't find something, at least you can simply make a screenshot for the presentation of your. You can put this one on the Kioptrix, on the recon directory, and you can name this one. You can write directory crawling. You can write one by one things. Either you can do the Nikto tool. Nikto is basically identify the misconfiguration file on the server side and the applications. So I'm going to use -h, the Nikto, and the IP address of the server to identify the vulnerabilities on the server side. Nikto is one of the best tools to identify each and every server misconfiguration files and loopholes on the server. You can write man and look for Nikto. So Nikto scan web server for known vulnerabilities. This is the main objective of Nikto. For example, what kind of vulnerabilities? It will look for the server with the software misconfiguration, default files and programs, insecure files and programs, outdated services and programs. And this one is basically used for the best part, for finding the vulnerabilities. So let's hit enter. So you can see that there are some directories like users, manual, icon, test.php. So it showed that this might be interesting, but we already looked at file, and we have some other things. For example, if you see over here, like this one, it's saying Apache 1.3.20 Unix Red Hat Linux system with the Mode Ssl services plus the OpenSSL services. And Mode Ssl and OpenSSL are the services which is running in the backend. You can say web server extensions. So sometimes the extensions are also vulnerable. You have to check each and everything. For example, you can look over here. Apache 1.3 and below 1.3.27 are vulnerable to a local buffer overflow, which allow attacker to kill any process on the system. So I guess this is this summary is like a DDoS attack, denial of service attack. Or if you look over here, you will find something Apache 1.3 and below 2.9 are vulnerable to overflows in mode read write and mode CGI. or you can simply check this one, Mode Ssl. That was an Apache server. Now this is a Mode Ssl 2.81.4. Or you can say Mode Ssl 2.8.7 and lower are vulnerable to a remote buffer overflow, which may allow a remote shell. And we have a CV Mitra also, a vulnerability over there. So this Mode Ssl is saying that there is a buffer overflow attack on the server side. So we can open this one, and it will redirect to us the CV Mitra website, and we can see the contents over there. So DBM and SSM session cache code. But before that, what is the use of Mode Ssl? If you talk about the Mode Ssl, what is the use of Mode Ssl? That's the important part. If you are making a report, you have to write each and everything on the server. So what is Mode Ssl in Linux? Mode Ssl is an optional module for Apache HTTP server. Okay, it's provide a strong cryptography for Apache version 1.3 and version 2. Web server via the secure socket layer, SSL version 2 and version 3, and transport layer security for version 1. Cryptography protocols by the help of open, secure SSL and TLS toolkits. Okay, so Mode Ssl is basically used for encrypting the data from the client side to secure the communication skills. Okay, so that's cool. But over here we can see that it has some vulnerabilities. So Mode Ssl before 2.8.7 and 1.3.1 and Apache SSL don't properly initialize memory uses, okay, of the session function. Okay, there is a vulnerability in the IDO SSL session function, which allows remote attackers to use a buffer overflow to execute arbitrary code via large client certificate that is signed by the trusted certificate, the CS certificate. Okay, which and HTTPS also, which produce a large number of serialized sessions. So we have attack, but where we should look this one? We can simply look this vulnerability on exploit.db. So let's write Mode Ssl 2.8.7. So when I write 2.8.7, I can see some vulnerabilities over there. So what was the version of our Mode Ssl? So we see that we have the port 22 over there. We have 80 port, that's okay. We have 111 RPC1. We have the port number 139, which is a Samba server also. We're going to look for this one, and we have 443. And the Mode Ssl version was 2.8.4. Okay, that's cool. If it's 2.8.4, but if you look over here, the Mode Ssl 2.8.7 and lower are also vulnerable. So if you search for 4, there will be no output. If you remove the 4, if you write 2.8, you will see some vulnerabilities over here. And some are DOS attacks and some are remote attacks. And you can see, and they are from the year of 2002 to 2003, and there's an upgradation of 2019. And we can see these are remote types, and a platform they are using is Unix. And we can see DOS is not countable, and we can see the authors. So we can try any of these vulnerabilities on the server side. So I'm going to try with the first one. So we can see off version, root verify, spam, requirement, libssl, apt get install libssl. Okay, we have to, there's a dependency. We have to install libssl. And if you want to compile this file, they have given the command gcc-o, the name which you want, and the exploit name, this alcrypto, and the object where this attack has been done. So you can see the attack is happening on through the Apache server from the user has been HTTPD configuration file. So this attack will be happen from the Apache server with a large buffer memory. So Apache Mode Ssl 2.8.7 OpenSSL, the number remote buffer overflow. So we can download this one. So I'm going to download this, and I'm going to try this one. Is it working or not? Because information gathering is the important part. So before this, let's see. We have to download the dependency. So we don't have libssl. So I'm going to use apt get update. Reading packet has been done, but still we don't have the certificate. Why is this happening? Because when you install your Kali Linux, so all you have to do is to edit your etc apt sources.list directory. So I didn't update my Apache server, so I need to update the repositories. So whenever you install your Kali Linux in the very first time, remember first you have to edit your repos over here, source lists. So we're gonna go to the website called Kali repo. You can see the very first one, Kali repo repositories. So I have to download this one by one, all the things. Default network repository values. So either you can copy this one or either you can copy from this. So I'm gonna copy one by one all these things in my over here. You can use the echo command they have given, but I already opened the nano command. Okay, let's see. Control X for save. Yes. apt get update. So remember one thing, when you install Kali, please update your repo for the new resources to be get fetched, and this will be done in a few seconds. So now this one is done. Let's try the dependency, and this was the libssl. And if I install this one, I can see the file has been fetching. So it's a 8 MB. Yes, install this one. Processing trigger. Yes, now it's done. So if I write which command, libssl. Okay, what was the name of that? Libssl dev. Okay, I have to write this one. So okay, it's not showing us that it's installed or not. Okay, not a problem. So what I'm going to do, I'm going to go to the downloads and I'm going to copy this one. I'm going to copy this one and I'm going to go to the website called Kioptrix, and I'm going to make a folder called second one. I'm going to name this one exploit. So over here we have an exploit. So ls all, and we can see that this is a C program file. If you write the file utility, you will see the sky. Okay. So remember one thing, when you are using a public exploit, follow the instructions. So I'm going to use GCC, the G compiler. So we're going to use GCC for compile the file, and I'm going to use -o for the output, and I'm going to use any of the names. So for example, I'm going to use the name called exploit, and the exploit name plus the encryptor at the encryption stack. So if I hit enter, the compile has been done, ls all, and I can see the exploit is over there, and it has a read and write and execution permission. So what we can do, we can try this file to be exploited. Okay, so this one is working properly. And we have the exploit. And we know about this exploit. This exploit will work, will affect on the Apache server with the HTTP configuration file. So let's see the uses. And we can see the target supports the target over here. Okay, the target over here is support the box example 0x0. So 0x00 is a buffer memory. You can see over here. These are the buffer memories. Then the box, the host name or the IP address. Okay, and the port number. This is the connection. And the -C, the open number of connection. You can use the connection from the range from 40 to 50 over here. Okay, so I have to use the buffer memory according to my, and I can see these are the server names plus the Apache version. Okay, so I have to pick my server name plus the Apache version. So over here, if I look the Apache version which we are using is Apache 1.3.20, and that was a Red Hat system. Red Hat. So we're gonna look for the exploit, and we're gonna see, and it was a Red Hat. Okay, we have Red Hat over here, and our machine which was showing that it was Red Hat Linux. They didn't mention the version, but over here on the browser, you can see if they said if you upgraded from Red Hat Linux 6.2. Okay, so 6.2. So this was Red Hat Linux 6.2. But the 6.2 has Apache version 1.3.12. And our Apache version has 1.3.20. So we have to look for the 20. And if I go over here, okay, see this one. See this two, 0x6A, 0x6B, and they are from Red Hat Linux 7.2 and the exact Apache version 1.3.20. See over here, you will see the Apache versions with the server names. Apache 1.3.24, 26, 26, and their version difference. So we have two buffer memories, which is 0x6A, 0x6B, and we know about the Red Hat Linux 7.2 and the Apache version. So according to this server, I'm going to use this method over here. So let's use exploit. I have to use the 0x6A first, according to the box and the IP address. And it said that we need to use the port number also. We need to know the port number. So over here, we're going to use the 443 port number to transfer our connection. So why I'm going to use the 443? Because the 443 is open over there on the server side. So we can use this one. So over here, 443 and the number of connection from 40 to between 50. So number of connection over here for 40 to 50, it means the sending the number of requests on the server side. If you use 40, it will send the number of requests 40 times. So sometimes you have to change the record. So you can see it's saying bye. So let's increase the connection. Let's use 45. Still it's saying goodbye, so it means the exploit is not working. So as per there was two buffer memories. One was 0x6A and one was 0x6B. So which we used 0x6A. So I'm going to use the 0x6B over here. Let's check the different buffer with the connection. Okay, so this one is working, and we can see the connection has been establishing on the establishing SSL connection, and it's basically over here. You can see the bash command, and the bash command executed this kmode gcc exploit ptrace kmode.c in the user bin directory. With it removes the ptrace kmode, and you can see the packet over here. This was a vulnerability. And you can open the file. This was a proper exploit of a buffer. So the main objective of this machine was to simply enumerate the server sites. And the main objective of the machine was to simply check each and every services. So why? Because you can see the attach has they attached to the port number 6607. Single caught, shell code placed, and now waiting for the UID shell. UID shell means ID. If I write ID, I'm just putting a commands over there, and it's basically executing. And I can see, if I type ID, you can see the root. If I write who am I can see showing us root. We get a simply root access on the server side. Let's bin bash -i interactive to get a proper shell over here. And we can see that we have a proper shell on the server side. And if you have a proper root shell, and you can see the exploit we have created, which is running as super binary. And we have a root access. A root access is the biggest thing. If an attacker get a root access, it can do a lot of things on the server side. So the main objective of your machine, this machine, was to get a root access on the server side. If you can go to the root directory, it's the biggest. So the most important part of this machine was to get a simple animation part.